Okay, so in this lesson we're going to talk about application problems involving exponential and logarithm equations, or functions rather. And so here's some examples of these application problems. So you have this formula, and this formula right here models the population of California in millions, and it's T years after 2010. So my function that models this population is A equals 37 times e to the 0.0095 t. All right, now remember when we talked about those formulas, we talked about the fact that A equals P times 1 plus R over N raised to NT. So we use that formula as being compounded a finite number of times. And we use this formula right here for continuous compounding. All right, so continuously. Okay, so here you're told that this. Now remember this is when we talked about compounded interest. So what I'm about to do is talk about this P, or remind you about this P. That this P is the principle in terms of compound interest. Compound interest. Now, this problem here does not talk about compound interest, but that idea about this 37 is the same about the idea here. Okay, so here's the question. What was the population of California in 2010? All right, well, remember, T represents the time after 2010, the time in years after 2010. Well, in 2010, T is 0 in 2010. And so if I plug in that the 0 into T, in for T, I get this. I get 37 times E. So A equals 37 times e to the 0.0095 t, which is 0. And then this exponent, 0.0095 times 0 is still 0, so I get 37 e to the 0. And e to the 0, remember, is 1, so 37 times 1 is 37. So that's what your answer is, 37 million. You got to say million, though. But what the point is, though, that the 37 here is the initial population in 2010. So remember, you're told that T years after 2010, so that's what this represents. So in 2010, T is 0, which means that you're going to end up with 37. But this is 37 million. Okay, now here's the next one. When will the population of California reach 40 million? All right, so this time, you see over here, you were solving for A. A was the amount you're looking for. So the amount in 2010 was 37 million. Here, though, you're looking for T, so you're trying to find the time. You're finding the time. So you're trying to get T by itself here. So that means you got to know A. Well, A is at 40 million because they want to know, you want to go from 37 million to 40 million. So this is what you're going to set up. You're going to say 40 equals 37 times e to the 0.0095 t. That's what you end up with. And now you got to remember how to solve an exponential equation. So to solve an exponential equation, remember you're gonna make sure that this coefficient of the exponential is 1. So you have to divide both sides by 37. So let me go ahead and rewrite this over. 95t. So you divide both sides by 37. And so you get 40 divided by 37 equals, and the 37 is divided out, so that equals e to the 0.0095 t. That's where I'm at. Okay, so remember the previous lesson, though, you're trying to solve for t, so you got to take this exponent and pull out in front. You got to get this exponent, the variable out of the exponent. Well, remember how to do that. You take the log of both sides. So either you take the common logarithm of both sides, or you take the natural logarithm of both sides. But remember, we talked about the fact that if your base is 10, you're going to take the logarithm of both sides. If the base is e, you're going to take the natural logarithm of both sides. And notice that here the base is e. So we take the natural log of both sides, the natural log of 40 divided by 7, and the natural log of this. And so I get this now. I get the natural log of 40 divided by 37 equals, and now I can pull this out in front. So I get 0.0095 t times the natural log of e. So 0.0095 t times natural log of v. And this is what you got to remember, though. Here's why you want to use the natural log, because the natural log of v is 1. And so you're just left with natural log of 40 divided by 37 equals 0.0095 t. And all you have to do now is get t by itself, because they did ask you to round. Where was it? Okay, but let's go ahead and round to the nearest tenth of a year. So let's round. So I'm going to divide both sides by 0.0095. And so t is going to be approximately equal to, now on your calculator you're going to say natural log of 40 divided by 37 divided by, say, equal then, and then divide by 0.0095. So let's see what I get here. 40 divided by 37 equals, and then take the natural log of that. Okay, so then we divide by 0.0095, and so t is going to be 8.2 years. So that's your answer. So in 8.2 years, so California will reach 40 million in 8.2 years. Okay? Alright, so that was number 1. Okay, number 2. Number 2 and 3 is where you start talking about compound interest again. So let's get 2. How long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest rate compounded quarterly? Alright, so remember, that's where we're going to use this formula. A equals P times 1 plus R over N raised to the NT. That's what you have to use. Now you see where it says how long? So that means time. So this is time. So you got to solve for t. But t is in the exponent, so that means at some point you're going to take the log of both sides. To get the t out of the exponent, you're going to have to take the log of both sides at some point. Well, let's just go ahead and plug in what we know. So we want $1,000. So $1,000, remember, is going to be the initial amount, so that's P. 3,600 is what you want to end up with, so that's A. So you say 3,600 equals 1,000 times 1 plus R. R is 8%, but remember you must write it as a decimal, so that's 0.08 divided by N. So compounded quarterly means every 3 months, so that means N is 4. All raised to the N t power, so 4t power. Alright, now remember, in order to take the natural log of both sides or the log of both sides, this coefficient here has to be a 1. So you see, that's why we divided by 37 to get this coefficient here to be a 1. Then I can take the log of both sides. So here, I got to do the same thing. I've got to divide both sides by 1,000. So if I divide both sides by 1,000, 3,600 divided by 1,000 is 36. I get 36 equal, I'm sorry, it's not 36, it's 3.6, excuse me, 3.6. So 3,600 divided by 1,000 is 3.6. So 3.6 is going to equal 1 plus 0.08 divided by 4 raised to the 4t power. All right. And now we're going to take the log of both sides of the natural log. Let's just take the natural log of both sides. Natural log, just like this. And so I'm going to get natural log of 3.6 equal. Now I can take this 4 and rewrite it as a product. So I can put it out in front of this. So I get 4t times the natural log of 1 plus 0.08 divided by 4. Now I see this right here. Let's go ahead and see if I can simplify this. 1 plus 0.08 divided by 4. So write this as a decimal. You can go ahead and this terminates. So just write this as a decimal. So you're going to get 0.08 divided by 4 plus 1. So this is really, oops, messed that up. Do it again. 0.08 divided by 4 plus 1. So yeah, 1.02. So I get natural log of 3.6 equals 4t natural log of 1.02. Alright, now in a previous lesson we saw that to get t by itself, you're going to have to divide both sides by 4, because you need this 4 to divide out, but you also need this to divide out, so you have to divide it by this product then. And so notice when I divide both sides by this product, when I divide both sides by the product, the 4's divide out, the ln's divide out, and you're left with t. So t is going to equal 4 natural log of, the natural log of 3.6 divided by 4 natural log of 1.02. Alright, so that's what I end up with. Now let's approximate this. Okay, so to approximate this, you're going to say the natural log of 3.6, and natural log of 3.6. Then we divide that by, alright, so 1.02 natural log times 4, close the parentheses, press equal. It looks like it's 16.2 to the nearest 10. So 16.2. So what that means is that in 16.2 years, it will take 16.2 years. It will take 16.2 years for $1,000 to grow to $3,600. Okay, so that's what that means. So it will take 16.2 years for $1,000 to grow $3,600. Okay, let's look at this one. So Maria has $1,700 to invest at 7% per year. How long will it take? Will it take it to reach $2,900 if it's compounded monthly, and if it's compounded continuously? Well, the same idea is going to apply as the one we just did. So you want to go from 1,700 to 2,900, and you know the rate, and you know that the n. You know n. N here will be 12. So I'm going to get 2,900 equals 1,700 times 1 plus n, which is 0.07, divided by n, that was r rather, r divided by n. N here is monthly, so that's 12, raised to the nt power, so that's 12t. So I'm talking for t. Alright, now dividing both sides by 1,700, because this has to be a 1. Dividing both sides by 1,700. I get 29 divided by 17. So this just leaves a fraction. So 29 divided by 17. They're both divisible by 100. So you get 29 divided by 17. So 29 divided by 17 equals these divide out. So you get 1 plus 0.07 divided by 12 raised to the 12t power. Okay, now I'm going to take the log of both sides because I'm trying to get this exponent, the variable out of this exponent. So I'm going to take the natural log of both sides. So the natural log of 29 divided by 17 equals the natural log of 1 plus, and let's just go ahead and see if I can write this as a decimal instead of writing it as two fractions. 0.07 divided by 12. Yeah, so this will be 1.01, all raised to the 12t power. Now, since I took the natural log of both sides, I can now take this exponent and write it as a product. So when I write as a product, I'm going to get the natural log of 29 over 17 equals 12t times the natural log of 1.01. Alright, but remember, we got to get t by itself. So right now, I am multiplying it by 12 natural log of 1.01. So the opposite of multiplication is division. So this is how it looks. So you have to say 12 natural log of 1.01. So these 12s divide out, these divide out, and left with t. But again, what you do to one side, you have to do the other. So this is 12 natural log of 1.01. Alright, now, so t equals this right here. So let's use the calculator to approximate how long it will take $1,700 to grow to $2,900 at that rate. So the natural log So you're taking 29 divided by 17, and then I'm going to take the natural log of that. Alright, so then I'm going to divide by, in parentheses, you're going to put that in parentheses, parentheses, 12 times the natural log of 1.01, natural log, then close the parentheses, and then press equal. Oops, that's fine. Press equal. It looks like a t is 4.5. So how long will it take 1700 to reach 2900? 4.5 years. So it will take 4.5 years for 1700 to grow to 2900. Okay? Alright, now let's do the compounding interest. So this time is being compounded continuously. Compounded continuously. Okay, well, same information going from 1700 to 2900, but this time is being compounded continuously. So that's where you have to use that the Prt formula. So this is 3b. So we have to use this. A equals P times e to the RT. Okay, so again, I'm going from 1700, so that's your initial amount. So you start out with 1700. You want it to grow to 2900. So you say 2900 equals 1700 times e to the R. R is here 7%, so that's 0.07 times t, which is what you're looking for. Okay. All right. So again, I got to get this to be a 1. You have to get this to be 1, so I'm going to divide both sides by 1700 first. And then these are both divisible by 100, so you get 29 over 17 equal, and these divide out, so you're left with e to the 0.07 t. Alright, now I can take the natural log of both sides. So I'm going to take natural log of 29 divided by 17 equals the natural log of e to the 0.07 t. And now remember, it's at this point that you can now take this variable out of the exponent. So using the power property, the power rule. So you get the natural log of 29 divided by 17 equals negative 0.07 t. Alright, is that a negative? I'm not sure. No, that's not a negative. I'm sorry. I'm not sure what this is. Okay, so that's 0.07 t, excuse me. So, so when you pull that out in front, there's going to be 0.07 t times the natural log of e. So that's positive, though. Make sure that's positive. Okay, now you have to remember that natural log of e is 1, and so you just left with 0.07 t. So you get the natural log of 29 divided by 17 equal 0.07 t. And then remember, you got to get a variable by itself, so the next step is divide by 0.07. And then 0.7 is divide out, so you get t equals natural log of 29 divided by 17 divided by 0.07. So that's the exact answer. And then to approximate this, okay, if y'all doing it on your calculator, the one that we've been using, the common calculator that we've been using in class, you make sure you get the same answer. So this calculator is not the same one as you're using, so things have to be done in different order on this one. So just make sure you get the same answer here. So I got to do 29 divided by 17 first, and then take the log of that, so the natural log. Alright, and then I got to divide by 0.07. Looks like I get 7.63. So that means, remember that's t, so that means that it will take 7.63 years for $1,700 to grow to $2,900 compounded continuously. So it will take 17.6 years. Okay, so let's leave it like that. Alright, so that takes care of this lesson on applications.